So good morning on this very, very cold day. We're at the Dog Groomers today, dealing with some electrical problems, and had to get up here very early this morning, which is why I've not had a chance to have a shave this morning. So, why are we here? Well, the Dog Groomers phoned me up and said that one of their sockets had got hot and was tripping their RCD. I must say that I came in here last week to try and have a go at this problem. So what I'm going to show you is what I did to fault find it. I actually know what the fault is. So it's had electrical problems in the past. We know that some of the stuff in here has been a DIY job. I have seen it as I've gone round. It is a bit of a mess. I'll show you bits and pieces in a minute. But effectively what we've got is what I thought originally was a ring circuit which had a fault with it. I wasn't getting any continuity. Turned out actually that it's actually two radials connected into a 16 amp circuit breaker. Now this shop has a subfloor, and a lot of the cables are going under the floor. Now behind me there's a radial circuit, and that goes all the way around behind me. There's a couple of sockets here, heads up into their back room where they do their dog grooming. We're in the reception area right now. On the other side of the wall, behind the camera, there's another route that goes off to the back room, and there's sockets on that wall. We have another circuit, which apparently was a DIY job, which runs to a socket on the wall there, behind the camera, to a desk where there was a barber's originally. There's sockets on that wall, and then there's another socket high above the hatchway. So, and there's another circuit in the back room which I'm not going to be touching today. So what we have, both radial sockets have got a fault on them, and I'll show you what I did to find out exactly what that fault is. So first thing we're going to do is I'm going to show you the fault on the circuit behind me. Right, so here's the inside of that board. As you can see, it is a bit of a mess. As you can see, I've did this. This is what I did last week. It's all off. I've done the test. I've labelled up this so I know what's going on here. So this is the right-hand side of the building, looking as if I'm looking out. So what I'm going to do is I'm going to hook up my jumper cables, jumper these off, and then I'm going to show you what I do with the far plug. So I'll get this all jumpered up, and the next thing you'll see is I'll set this camera up over on the far side with my test rig, and I'll show you what goes on there with the continuity first. And then, so I'll do the continuity line to CPC, I'll do continuity line to neutral, and I'll do neutral to CPC so you can see all three continuities, and then we'll do the IR test, and then you'll see what's wrong. Right, so pull that up a bit. As you can see, I've got my crocodile clips clipped onto line and CPC, and it's all jumping at the board. As you can see, we're getting a reading of 0.51. I'll just press it again. So for the length from there back to the board, 0.51 would seem to be a bit on the high side. So let's see what we get when we jump neutral to CPC. Okay, so let's just swap that over to neutral. There we go. Let's see what we get. 0.48. Okay, so the readings are pretty much within the margin of error, pretty much the same. So let's see what we get when we do line to neutral. Let's see what we get with that. 0.54. So pretty much all the readings are near enough the same within a margin of error. So there is a continuity of a type. It seems to me, given the run, seems a bit high, but there's continuity there. So let's do the IR test. Okay, so that's unjumpered that end. So let's do the line to, while we're connected up, let's do the line to neutral IR test. So we'll switch it to 250 and we'll just do it at 250 to start with. So you probably saw on the display, it was struggling to get to the 250 volts, and that's the reading we got, 0.049. Now the minimum is 1 mega ohm. Between 1 and 2 mega ohms, you've got to really do some investigation. Above 2 mega ohms, it's considered a pass. We're nowhere near that. So there's obviously a problem with the cable between line and neutral. Let's have a look at the other cables. Let's have a look at the other conductors rather. Let's see what's going on. So we're going to do line to CPC now. Let's see if line to CPC has got a reading. That's even worse. So that's not good. So let's see neutral to CPC. Oops, that's not connected. And neutral to CPC, let's see what we got. Add as well. So there is a fault from this cable going back to the board, and that's going under the floor. That's what's potentially tripping the RCD out, to be honest. So we've got a dead short somewhere along this cable, probably due to rodent damage would be my guess. Now, just for completeness, I'll just raise that up. The other cable there is running off to the back room. That cable has been fully tested, continuity and IR are perfectly fine. Above 2000 mega ohms actually when I measured it on all the combinations. So there's no problem from that cable going to the back room. The problem on this side of this shop is the cable going back to the board. That is shot, basically. It's, in layman's term, buggered. So, okay, so we know that. Now we'll go into the back room and we'll do the same test over there. And I'll show you what's happened with that one. Slightly different. Okay, it's a little bit more difficult to see, and I apologise for the flickering. That's to do with my light that I'm using. Now this is the one that we're going to be doing. This is at the end of that other radial circuit. So we're just going to hook these up and we'll take a reading from these. Easy to get the cables over to this really. Let's see what we can do here. It's not easy to do this when you're trying to film at the same time. Anyway. Twisted. Okay, let's get this. No, that's not going to sit there properly. Right. Okay, let's do it the hard way. The first thing we're going to do is we're going to test the continuity on the line to CPC, and I'll be back in a second. Can you see that? Yeah, just about. Right, so let's jump it together. Oh dear, I don't think you'll be able to see this. Let's just do that. So we get, as you can see, we're much further away from the board and we're getting a much better continuity. See, it shows how badly damaged that other cable is, so there's no problem there between those two. So let's do line neutral. Let's see what we get for that. Okay, so they're hooked up line neutral. Hopefully again you'll be able to see this. 0.3 on that one. That's absolutely fine. And let's do neutral CPC as well. Okay, let's have a look. Line neutral continuity. Hang on, what am I doing? Oh yeah, sorry. Neutral CPC seems fine. So the cable seems on the face of it to be okay. Let's do an IR test. Right. So let's do an IR test. Line neutral. So we'll set it to 250. Don't have to, but we'll do it with 250. Let's see what we get. Line neutral. There you go. No problem with the line to neutral. Greater than 2,000 megaohms. And you saw the voltage was 250 volts DC. No problem there. Just for completeness, let's do 500. Voltage steady. Greater than 2 megaohms. So there's no problem on that. Let's turn it off for safety. Let's do neutral CPC. Let's see what we get now. That's 250. Getting 2 megaohms. Let's do it at 500. No problem there. So let's do line CPC. I haven't done. Get that up properly. I think. So we're doing line CPC now. And as you can see, we're getting a very different reading now. We're at a steady voltage, but we're only getting 3 megaohms there now. Let's do it at 500. .4 megaohms. So it's a pass because it's above 2 megaohms, but it is showing that there is a problem with this cable as well. What that problem, the problem is between line and CPC. Line to neutral was fine, neutral to CPC was fine, but there appears to be a problem between line and CPC. A much lower reading, much lower. But so there is this cable running back is suspect. It would pass, but it is suspect. And in actual fact, what I will say right now is when I did this test last week, that IR test between line and CPC was actually 6 megaohms. So it's dropped another 3 megaohms between last week and this week. So something is going on with this cable. It could be something is nibbling it, just like I think it's my suspicion in the other. So I don't think this cable going back to the board is going to last much longer, if I'm honest. Interesting. So we are landed with a bit of a dilemma. How do we fix these faults properly? Well, what I'm going to do next, is I'm going to check the barber's circuit that's been put in and see if that is perfectly fine, both for the IR tests and for the continuity tests. I also want to check the cabling. If the cabling isn't going into the subfloor but going through the wall, there's a possibility that there's no way that I can get any rodent damage. It might be a cable that will be fine. The issue we've got, I'll just turn this camera around. So what my plan would be, which is a bit difficult when, it's a bit difficult, it's a bit dark in here. We would come through the wall there and I would surface mount some D-line, some D-trunking around the wall. I do know this cladding in here is actually being removed at some point in the future. It is very difficult to do this. At some point in the future, this cladding is being removed. It's very difficult. It's very dark, so I do apologise. Yeah, so I'm going to put in some trunking, and that'll probably do this fault. But what we're going to do first is we're now going to have a look at the barber circuit and see if that is absolutely fine for me to use. And we'll come through the wall there from behind the socket. If that can't be done, I'm going to have to scratch my head over this one on how to liven up these cables. But let's go and have a look at that and then let's see what we can get. Right, so plug socket's a bit high up, so you can't really see that. I'm doing the line to neutral test here, which is 0.35. I'll just do it again. Hope you can see that on the camera. There are two cables going into there, so one's going off to the barber's things, and the other cable's going off I don't know where yet, but I'm not overly concerned about that right now. I just want to make sure I've got a good circuit I can use. So I've done the line CPC, that was fine as well. I'm just going to do the neutral CPC, make sure that's okay, then we'll do an IR test. So, neutral CPC test, let's see what we get. Neutral CPC. There we go, neutral CPC. Absolutely fine, I'm getting the same figures all the way through. So let's do the IR test and see if we've actually finally found a good circuit in this place. That's all disconnected back there. So we're going to do an IR test now. Yeah, let's do 250 volts. And we might as well start with neutral CPC because they're the ones I've got connected. So. Okay, it's not greater than 2000, but 1141. Oh, that's okay. I can run with that. Let's do it at 500. Oh, hang on. 1 second before I do anything else. Just realised we've got things plugged in here. Just feel well, we're not getting good before lower than that. Let's just unplug this stuff. Plug it all back in for a minute. Right. Let's try that 250 again. I'll just connect to everything I can see. Yeah, something else connected in. Let's try that 250 volt again. There you go, greater than 2000. That's why you should unplug things. Right, I could safely do a 500 one now. There you go, greater than 2000. Right. Yes, that was a noddy mistake there. Right, let's do line neutral and make sure we've got that's absolutely fine. Right. Yay, good, good. Let's do 500. Yo, 500 is good. Okay, last one, line CPC. Let's see if we've got good on that as well. Oh, it's looking promising. Yay, good. We have a good circuit. We have a good cable at last. Right, so what that means is I can extend this circuit out to the back room, go through the wall there, put in some surface trunking. Like I say, they're removing the cladding in there at some point in the future. So what I want to do is do something that's safe, but it doesn't need to be permanent at this stage. So get that in there, get those, I can get all those plugs back up and working, the plugs on that side of the wall working using this circuit. The way the wiring's been done under there isn't great, so that probably needs me to do tidying up. The last thing I'm going to do is I'm going to open up the socket nearest the board and just see where the cables are going. I'm really hoping that they're in the wall and they haven't gone into the floor. So we'll just have to wait and see on that. Let's have a look. I'll take a screwdriver. So there we go, so just to end with. So, showing you what the problems are with these two circuits. This one behind me, that's dead. The other one going the other way, it's on its way out, as we saw. But we do have a good circuit where that the barber's circuit that was put in is good. We can use that, and you've seen behind the desks there the state of the cabling, so I'm going to tidy that cabling up, make sure that's okay. But that cabling isn't going into any of the subfloor, I've confirmed that, so that's even better. So, need to talk to the client, and we need to get that work booked in, and then we can liven up with their back room. They can get round at the moment with their business by charging up all their bits and pieces in here, and then working on the dogs in the back room after that. But we obviously do need to get those plug sockets done. You can see that they're in a really bad state as well, so I might even replace the socket fronts. But that's for another day. So, I'm off, I've got to do paperwork now. Fantastic. It's always the good part of the job, and join me another time.